On July 8, 2011, NASA carried out the last Space Shuttle mission, marking the end of an era that had begun 30 years ago with the launch of Columbia on April 12, 1981. Since then, there has been no manned space launch lifting off from American soil. That is, until now. On May 30th, 2020, NASA and SpaceX carried out the first manned mission of the Crew Dragon 2, a reusable capsule designed to transport astronauts to the International Space Station and docked on top of a Falcon 9 rocket. But why did NASA take so long to send astronauts into space on an American rocket? The Space Shuttle program planned to create a reusable spacecraft system to supply a future space station. This and many other projects proposed by NASA for post-Apollo missions were considered during a time when NASA's budget was being severely restricted. On January 5, 1972, President Nixon announced that NASA would begin developing the shuttle in order to transform the space frontier into familiar territory easily accessible for human endeavor. This was to be achieved through approximately 50 missions every year. With this many launches every year and a reusable space shuttle, NASA hoped to lower the costs of each launch. During the early stages of the shuttle's development, there was a lot of debate about the optimal design that will bring the best combination of performance and operational costs. However, and despite the great efforts of NASA's engineers, the Space Shuttle program never lived up to its promise and received much criticism for not having achieved the expected objectives, as well as for the accidents of the Challenger in 1986 and the Columbia in 2003. During the years that the shuttle was in use, NASA and other partner companies explored possible alternatives to the program, but none of them went beyond the initial design phases. The HL-20 was cancelled in 1993, the X-38 cancelled in 2002, and the Constellation program with the RS-1, RS-5, and the Orion capsule cancelled in 2010. It turns out that developing a reusable and cheap launch system is not as easy as it sounds, but it's even harder to do it while other missions are carried out at the same time, especially due to the low budget that NASA received. Finally, the Obama administration chose to shift the responsibilities for the space station maintenance to private sector companies, such as SpaceX and Orbital Science. Meanwhile, the station will be supplied using the Russian capsule Soyuz. After years of development and some other delays, SpaceX has finally delivered on its promise with the new Dragon 2 capsule, which has two variants, one for crew and the other one designed solely to transport cargo. The Crew Dragon 2 is capable of taking 7 astronauts to the International Space Station, remain docked for up to 210 days, and return to Earth thanks to its 4 parachutes. All of this while only costing $160 million, which is nothing compared to the $510 million that it cost with the Space Shuttle. Crew Dragon 2 also has 8 Super Draco engines located on the side of the capsule, each capable of producing 71 kilonewtons of thrust, hence the name Super, and which will be used to perform launch aborts, as it has already been demonstrated in various tests. Once in orbit, the capsule is capable of autonomously docking to the ISS. Dragon 2 also includes the 3rd generation Pika heat shield, which protects the spacecraft during the re-entry phases into Earth's atmosphere, where the capsule reaches temperatures above 2,900 degrees Fahrenheit and speeds of 17,000 miles per hour. This new generation of shields is stronger and tends to flatten much less than the previous version, helping to decrease the time between launches. All of the required tests, as well as the capsule's certification process, have been very extensive and expensive, causing major delays in the program. In fact, the first manned launch was scheduled for July of 2019, but due to the explosion of the Demo 1 capsule in a test of the Super Draco engines, the date was delayed until May of 2020. To understand exactly what happened, we must first understand how rocket engines work. Rocket engines need two chemical agents to work: the propellant, such as liquid hydrogen, and the oxidizer, such as liquid oxygen or nitrogen tetroxide. These two agents chemically react in the combustion chamber, generating high pressure and temperature gases that, when exiting through the nozzle at high speeds, generate the necessary thrust to lift and accelerate the rocket. Depending on the type of propellant, we can find three types of engines: solid, liquid, and hybrid, which are a combination of both. Launch abort systems, like those in the Apollo program, have typically always been designed from solid engines, which, as the name suggests, use propellant in a solid state. These type of engines are much simpler to manufacture, reuse, and tend to be more reliable. However, once started, they cannot be shut down until the fuel runs out. In contrast, liquid engines are more efficient and have regulating valves that control the acceleration of the rocket, and they can also be shut down in an emergency. But due to their complexity, they are very difficult to reuse. A damaged valve on the Super Draco liquid engine was the reason for the test pod explosion. However, SpaceX modified the valve design so that this will not happen again, which brings us to the importance of testing. It is essential to ensure that the design is capable of fulfilling the mission, and in case flaws are discovered, modify them in order to guarantee the safety of the astronauts and the cargo on board. And with this launch, a new era of human space travel begins, with the launch, once again, from American soil, of a manned spacecraft to the International Space Station. Perhaps it's not the most exciting achievement. After all, there are still many more complex missions on the horizon, such as returning to the Moon and reaching Mars. However, it is important to remember that this accomplishment lies in the economical aspect of space travel, by getting humans into orbit for a fraction of what it previously cost. All the innovations that SpaceX has been working on in recent years aim to lower the development and operational costs of the launches, and thus making space more accessible to mankind.